Welcome to Innovating with Scott Amyx. This is your host, Scott, and today I'm joined by Jake Loosararian, who is the co-founder and CEO of Gecko Robotics. Welcome.
Hey, thanks, Scott. Pleasure being on.
All right, so Jake, my first statement is, according to the American Society of Civil Engineers, they gave the nation a failing grade of D+ on our aging physical infrastructure, which really is kind of the context of what we're going to be talking about today. But first, let's talk a little bit about the work and the research you were doing at Grove City College that eventually led you to the commercialization of Gecko Robotics.
Yeah, absolutely. Yeah, so I was doing electrical engineering at school. This is actually where I met my co-founder, Troy. And, I'd been into robotics and a part of the IEEE, president of the IEEE club at school. Kind of always been curious, especially in the energy sector, but really didn't fully comprehend everything that went into being able to turn on, a light switch or be able to put gas in your car. And, I had a friend who was a power plant engineer right down the road with the power plant nearby our school. And he said to me his plant was about to shut down because they were only being able to operate about 60% of the year, meaning they were losing 40% of the year production due to infrastructure failure. And it was a small power plant. And he also mentioned that a year ago, someone had fallen and died trying to, fix these issues before they happened. So right then and there, I was thrown into the world, I guess, of infrastructure failure and the issues that they cause. And this plant was about to be shut down if someone didn't do something. So that's when I made the first wall climbing robot.
Yeah, I really like this background because we're talking about very large infrastructure. There's a lot at stake in terms of economic and financial, not only for the company, but in the case of energy sector, for the continuous and stable, supply side of energy. So in terms of my understanding of Gecko Robotics is that you guys develop robots that automate infrastructure inspections using non-destructive testing technologies. And I've seen some videos of it, and it's very, very interesting to see these wall climbing robots that typically, I guess, it would have been done by humans. So
yeah,
get into a little bit about the company itself, and I know you guys have several products within your portfolio.
Yeah, absolutely. So the idea of the company is that we want to mine physical data enables us to predict when things break. The idea is, we, just like in the software space, we're able to utilize machine learning and AI to be able to optimize and be able to make insights that we never were able to make before. But we can't do that as well if we don't have the right information. And so what the company is all about is creating ways to gather massive amounts of information on things that are extremely important to the fundamental backbone of our society and civilization, which is these heavy industries that always seem to get overlooked. And so in order to protect and maintain the civilization's most critical infrastructure, we have to literally go out and collect this information, these terabytes of structural integrity data, to be able to create software insights that help these companies be more efficient, as well as de-risk the human side. And so the robots, we have about 4 different series of robots that go out and do that. But the idea is, how do you create a robot that can be modular? And so you don't have to show up at an industrial site with 50 different robots to do 50 different types of inspections on infrastructure. Things like pipelines, tanks, silos, boilers. These are like the types of infrastructure that create power and push product through pipeline. And so we made robots that were able to do inspections on a plethora of different asset types, 50 different asset types for our main 2 platforms. And so that was some of the technology challenge that we had to overcome. Was these are not your lab environments. These are dusty, dirty, hot, cold, all these different elements, a lot of unpredictable asset types and configurations. The robot has to be able to adapt towards and also maintain the right settings for our advanced sensing techniques to be able to determine whether or not a structure has structural integrity or not, for them to be able to take action. And because we're able to do that, we've been able to save customers in some cases tens of millions of dollars, and also about a half a dozen explosions at refinery sites. We're working with some of the biggest companies in the world, like Chevron, Marathon, Exxon, Duke Energy, Southern Company. So we're predominantly in the U.S., but also do some international work as well. But the rate of adoption has just been pretty massive for what we're doing.
All right, so you started to kind of get into some of the specific examples. Maybe you could give us an example or two around how your technology was able to help prevent a failure, downtime, or disaster.
Yeah, absolutely. So one of the use cases was we were doing work at a power plant here in the southern eastern part of the U.S. in Alabama. And this power plant was having about 6 to 10 shutdowns per year, which basically, for your listeners, means that the site has to actually shut down, and that piece of equipment can't actually make steam to turn turbines and generate power. So literally, they're losing millions of dollars every single day that they're down, and this is happening 6 to 12 times a year, and that's just kind of how things are. And the only way to stop things from breaking are to send humans into these dangerous environments up a couple 100 feet up in the air, and to spot checking and trying to find that one little spot in the midst of hundreds of thousands of square feet that is going to cause something to break and to cause an explosion. So what Gecko did is we came in after we secured the contract and bidding out against the manual competitors. We found about 50 different locations that were going to cause the site to have a failure or an explosion inside of their asset. And so we increased that piece of equipment productivity. They calculated by the end of the year by 85%. Now it's important to note that, again, every single day that piece of asset is down, it's causing this plant not only to not be able to meet the the requirements of power being produced, but it's also when you have all these shutdowns, it's really bad for the environment, because when things aren't working the way they should, it actually the emissions levels spike at these facilities, which also hurts the power plants or the refineries and their ability to produce. And a lot of people don't realize this, but structural integrity actually drastically affects our emissions levels with the most emissions heavy industries. And so if you can reduce these shutdowns and eliminate them, as Gecko is trying to do through predictive analytics and the data we're collecting in the real world, we can actually reduce our emissions levels drastically. I'm talking 10, 20, 30%. So it's really exciting to see the green impact that the company is able to have, even in such, we'll call it, dirty industries.
Yeah, I think that's a really excellent point that you make in terms of the impact of the optimization and the integrity of structure, and how that affects the overall process and the output and the eventual carbon emissions. Great point. Let's go back to the name Gecko, which is I think symbolic of some of these robots that's able to crawl vertically. So talk to us about that. And then also, is it really sampling, or are you actually enveloping the entire physical infrastructure? So if it's a certain plant asset, are you covering the entire outer space? And then also, are you then translating that not just in terms of data and coordinates, but in terms of almost like a 3D model, like a digital twin?
Yeah, I'll answer the second question first. That's okay, and then go back to the first. So what we're doing on the inspection side is all the information that we're collecting. We also collect the coordinates and ensure that the inspections are repeatable year over year. A differentiation between human inspections and robots is robots can repeat the same inspection, which allows for us to see over time what the damage rates are, as well as operational data allows us to understand what's causing things to fail. But what we do is we built out a software as a service that we sell to our customers as well. And our inspection data, the health of the asset, is housed on that software. And so the software is able to organize and also visualize what's going on in the physical space. So if you're a refinery, what do my 20 different piping infrastructures look like in sections of the facility, and when do I need to fix, or when do I need to do more inspections again. And then we're able to, once we get more information, tell them into the future what they should be expecting from infrastructure damage or risk. And so it becomes, in one way, an asset management software for our customers, but it also becomes a reliability product. And so that's what we're working towards with some of our customers, is to give them more information so that they can not be surprised. And insurance companies love this, by the way. And then on the Gecko side itself, I was in college and building this robot out, and I wanted to take one last trip before graduating, and so I was working on the company, and just like, I just need to take a break. So my buddy had standby tickets to go somewhere in South America, and so I was like, all right, like, let's go, Ben. And so Ben and I waited at the terminals, and lo and behold, we got a trip to Costa Rica for like 4 or 5 days. So I was in Costa Rica, just couch surfing at the time. Airbnb wasn't that big back then. And one of the couch surfing places I stayed at, I took a cold shower because it wasn't very warm water there. And I just saw a couple of geckos climbing on the shower wall. And I was like, that's pretty awesome. And fits really well with how my robots look like when they climb the walls. And so it just kind of clicked and made sense. And that's how I came up with the name of the company. It was in Costa Rica, trying to get away from everything. And it's typically when your best ideas happen. But one thing I didn't touch on, with the startup story that might be helpful background is, it looks, the traction of the company is incredible now. We're one of the fastest growing companies in the United States. Robotics as well is not typically one you see breakout companies, forging ahead, but we've been able to unlock a really great business model in a really important industry. But it wasn't all, easy. And I think, like, there was the trough of despair for me was right after I started the company in 2013. There's about 3 years in which, I just poured into the company and bootstrapped it, and basically lost all my money doing it. It was down to like a couple $100 in my bank account, and sleeping on my best friend's apartment floor. And all of a sudden in 2015, I had enough traction with the company, got an acquisition offer from an OEM from the industrial space, and then YC. I met YC through a connection that my co-founder Troy, who's amazing, by the way, connected me with Kevin Hale from YC. I was the co-founder of Wufu, and from then we got an interview and accepted into YC. So I had to choose between the acquisition offer or YC, and we decided to build out the dream because we just kept on seeing time after time, year after year, that this was going to be massive, and the problem was something that we called the secret, and that no one really knew about. And so now it's great to be executing on that, but it wasn't easy from the beginning.
Yeah, thank you so much for sharing that and being so transparent, because I do think that many entrepreneurs that are not serial tend to focus on only the exit and not the journey, especially the formidable years like you're talking about.
Yeah.
I do want to go back to a little bit more of kind of the details.
Yeah.
Some of your products have specific hardware capabilities, and of course, there's the algorithm side as well. So let's break down. So Toka 4, which is your high-end product, has about 32 plus transducers, 4 high-def visual cameras, and of course, the vertical ascension is done through magnetic adhesion, which I have a separate question around. What happens if it's a concrete or some other substrate that doesn't allow for magnetic? But talk to us about the hardware, and specifically what types of data are you extracting out, and the signal processing and the algorithms on the dashboard side in terms of what are the customers actually seeing?
Yeah, great questions. So on the hardware side, we have about 6 different types of payloads that do structural integrity testing. And basically what we looked at is, in the field of non-destructive testing, basically how do you tell if something is broken that doesn't look broken. We identified 6 main technologies, the main ones being ultrasonic inspections, which have been the prevalent inspection type that we've done. And that's kind of viewed as the source of truth in the in the industrial world, in the non-destructive testing world, and all the boards. And so we really poured into that payload, but there's a few other payloads like laser profilometry, magnetic induction, a couple other payloads that we can strap onto the robot, really, really quickly. But what we're basically looking for is erosion, which is wall loss of material, as well as corrosion. So what's going on from a chemistry standpoint on the material itself, and we're actually working on weld inspection technology as well, which is a little bit harder, and stuff that a lot of rocket companies deal a lot with. So the sensors themselves are very sensitive, and we have to make sure that we set them up to be able to capture the base materials readings in good condition. So we built out payloads for the sensors themselves that have to adhere to a bunch of different types of platforms, and the signals that we get back, we have to interpret them on using our own algorithms in real time. And one of the things that we look to do is how do you do this inspection very quickly. So we accomplished that through different kinds of couplants, and as well as some electrical engineering on the board level to be able to allow us to climb at a foot per second and capture data continuously as we go. So we take all those billions of A scans, is what they're called, the ultrasonic signals, and we analyze them in real time, and we post-process them. And within 24 hours, we deliver the health report to the customer. And so they're used to seeing a couple thousand readings, and we're able to pull millions, even billions of readings, so that they can see exactly what's going on that just were missed before. So,
that's a pretty high fidelity. That's a significant increase from what they're used to. My last question before the lesson learned question is, this is really coming out of their inspection cycle. There's a certain schedule around compliance around inspection for safeties, OSHA, and so forth, and of course the budget as well. But ultimately, at some point, the holy grail is kind of ubiquitous, always on, real-time, continuous inspection or monitoring, so that, to your point, it's not just mitigating the bad, but also being able to actually support quality and being able to feed into insurance data as well. What is your kind of projection around the viability of the fidelity and the strength of modular sensors that you could, in fact, envelope kind of a mesh network of sensors on a physical asset so that you can, in fact, have continuous monitoring and reporting out?
Yeah, the technology that's being developed with continuous monitoring is there's a lot of R&D going into it, because, like you said, we want to be able to dashboard and have control, kind of like in control room, be able to have continuous readings on structural infrastructure or structural integrity of infrastructure. The sensors that we're finding that are coming out right now can only accomplish that at certain locations, which is a problem, because the issues that we're finding don't happen in the areas that the experts think they're happening in. Now, that's where typically, like, the bends and the welds are where a lot of problems exist, but that's not uniform. That's not true in all cases. Chemistry and oxidation happen in weird places that you just can't predict, and so that's why we have taken the approach of as much information as you can get at any given time is going to give you the healthiest report. And we're not there yet for continuous monitoring. We're looking at a lot of technologies that can continuously monitor in certain areas, which we are trying to incorporate actually onto our software. But actually, what we found to be even most useful with some of our customers who are a little bit farther advanced in their relationship with us is increasing the inspection cycles that they're used to, and using technology like Gecko's is a great way to do that in a cost-effective, but also an optimization and in order to optimize the way they're running and how efficient they are with their facilities at production, um, doing more inspections is just better to getting that information. And so we're seeing some customers change their inspection cycles, which makes sense because all they've had before have been humans and checking random spots. So you only get so much information out of that. So we're kind of seeing some change to the philosophy and what people are taking care of their assets that are worth millions and sometimes even more than that.
So I'm going to actually replace my last question, my final
Okay.
question, which is that, um, I've actually done a similar project in the Middle East for not steel, but more PVC
Yeah.
components, which are trickier to be able to apply sensors to.
Right.
Is that there's the revenue side from the inspection. Of course, the frequency only increases the revenue stream. But have you thought about the possibility of adding another service component that effectively almost insures or provides an SLA? So it's a revenue stream that basically says we're able to maintain the service level agreement of your physical assets, and for that there's almost like insurance contract, so to speak.
Right.
Is that something that you guys have entertained, and what could be the receptivity of your customers?
Yeah, it's a great question. We definitely entertained it and something that we have to take seriously as a potential strategy for the company. But I think the thing that we've understood about our customers, probably better than a lot of other technology companies trying to service this industry, is um, in a fraternal, antiquated, and sometimes slow moving industry, you have to be the customer where they're at. And that's why traditionally selling robots to this industry has been very difficult. And people have been trying to sell robots to these industries for a long time. Even some companies make their own, like BP and Shell. But the issue has always been robots just have a hard time working reliably and actually solving the problem that we're set out to make. And so we took a different approach and tried to have this customer service model because we wanted to own the customer experience and answer the question that we kept getting, which is, what do we do with all this information? But I think how that relates to your question is we're trying to meet our customers where they're comfortable and at the pace that they're comfortable with moving at. And then once we prove ourselves as a technology company, to them that are reliable, that can produce high returns on their investment, as well as solve problems that no other companies are agile enough to solve, that's when we can start entertaining like more of those conversations with executives. But sure, like this like that model works very well for both us and for our customers, and would be pretty exciting to work towards. But we want to be realistic about where our customers are at and how quickly they can change core philosophies. And we're interested in building that relationship so in the future we can be a little bit more creative.
I really like that pragmatic approach and customer centrism. And I think really understanding not only their willingness, but their appetite and readiness is super important for market entry and market further penetration. So with that, I've been joined by Jake Loosararian, who is a co-founder and CEO at Gecko Robotics. Thanks for joining today.
Thanks, Scott. It's been a pleasure.